on this one, you can see it's kind of like the same concept, XYZ system. The main difference, and I don't know if you noticed it, but that one over there was cantilevered, meaning that the Y was kind of hanging, right, by the X. And this one, it's supported, so you have two X's, and then you have a Y, and you have a Z. This one is really like a workhorse. These actuators, and those ones are great too, but this one has been in the market for a while now. It's a proven thing. And I think you are familiar with this. I think you've used it recently.
Yeah, we just deployed a project with 12 of these servo motors on it.
Nice, nice. So you had an experience with them, really, really reliable. Our customers love them. And what makes me really happy is that from a mechatronics standpoint, mechanical engineers love them and also controls engineers love them. And on this display, basically what we're showing is a different type of gripping. I don't know if you've seen this before. It's just like based on a chameleon tongue. So basically just picking different shape of objects.
Yeah, definitely very interesting. Yeah, and also you mentioned here, like how you have this configured in a different way mechanically where you have it double supported. That's gonna help you get like better accuracy out here. So like that way when you come to a stop position immediately, you don't have to pause. You can actually go directly down to your pick position and not have to worry about being off in like your X or Y direction.
The other thing with this one is the rigidity, right? On the back, you can probably see there's a drive shaft on the very back. Yep. And so meaning that you have one motor for the two X-axis. Yep. We've also worked on some projects where you actually have one motor for each axis. And that makes sense when it's too wide, that a shaft wouldn't be long enough.
Gotcha, so you have one motor, two motors for one axis then?
No, one motor here and one motor here. And basically what we do is we do a master-slave operation.
Synchronous type of...
Synchronous motion.
Yeah.
So basically one starts moving, the other one starts following immediately. So that way we're syncing both X-axis. So it would be like an X and X prime arrangement.
Yeah, that definitely helps with like having, like not getting as much torsion on the system.
Exactly.
Because right here it's like, you can get potential tweaking and it, depending on like how high tolerance your operation is, I mean, even if it's just torquing like a half millimeter, a couple millimeters, like it could throw off the entire precision of the machine.
Peak in place or whatever you're doing. And here's a pro tip for your audience. I know that you have audience from the mechanical side of things too. Here's a pro tip. Always read the user manual in terms of, like any product. And the reason why I say this is because for these type of Cartesian robots, there are instructions in terms of the flatness of the surface where you're going to mount it to. There is instructions on how to make them parallel. I've seen some applications where, picture this, you don't do it in such a way that these two axes are aligned. And basically, instead of being like this, they are crooked like this, right?
Yeah. So
So what's going to happen, it'll work, but basically you're reducing drastically the life of the ball bearings in there. I've seen applications where suddenly the ball bearings are, in the floor, but that is because of that. You have misalignment issues.
Yeah.
So just a pro tip right there.
I don't really see it on this particular mechanical setup you have here, but I know that you have like some hardware that gives you the ability to adjust that. So it's like set screw type of adjustments,
Right.
which makes it really easy to like kind of tune it in and get it exactly perfect.
There's an accessory for that. There's also an accessory that's kind of like a floating joint that will give you some compliance. So basically, if there's a little bit of misalignment, it'll correct that issue. So I always recommend, if you can get those, get them. It'll help you down the road.
So is this system here also, is it on the Festo platform as far as the PLC goes, or is it being controlled by another PLC?
No, in this case, let's see, so this is basically the PLC. And I'm really glad that you asked that question because you can probably see the difference between this one and that one over there.
Yeah.
So this is a electrical terminal that the first module is coded as PLC as well.
Oh, okay.
And then you have some other I/O modules, the second, third, and fourth. And then you have some valves, everything on one package. So
Are those your servo drives down there, or is that something else?
yeah, with a PLC embedded on it.
With a PLC embedded
So
on it.
it's PLC, I/O, and valves, everything on a single package.
Nice. Yeah, definitely this is another thing that we love. It's just the valve banks and just being able to configure the I/Os and, because we do like a lot of like quick fixture changes and stuff like that. And so just being able to remove your communication protocol cable, your power cable, air, and then you can swap it out with a whole new fixture and leave everything with it.